All right, today we're going to continue our discussion of parallel lines. Last time we talked about the fact that if lines are parallel, we know certain things about different angles. For example, we know that the corresponding angles are congruent, right? That sound familiar to you? Yeah, it's been a couple of days. What was the one that was different?
Same side.
Right, same side interior angles, when the lines are parallel, those aren't congruent, they are supplementary. It turns out that the same side exterior angles are also supplementary. We don't ever actually use them specifically, but if you want to, you're certainly welcome to. Okay, it's true. So let's take a look at some example problems. I like these first two because they illustrate an important point. It looks like these are exactly the same sort of diagram, and yet they are not. And I'm going to make one change to the first one in just a second. But you can't assume that lines are parallel just because they look like they're parallel. Okay? About the only assumption that we will make is that if it appears to be straight, that it's a line. Other than that, we won't make any assumptions about things until much later in the class when it gets too crazy to put everything on a diagram. It's like, it is what it looks like. Okay? So, for a problem like this, let's fix something here. This angle is pretty clearly not 54 degrees. Let's make it 154. It's probably too much, but it's closer to that than it is to 54. All right, when you're working with problems like this, part of what you have to do is figure out which angles are in a relationship with one another. So for this one, if we're looking for angle 1's measure, is angle 1 in a relationship with the 64 degree angle, or is angle 1 in a relationship with the 154 degree angle?
No, it's in a relationship with the 64.
Wait, I can only listen to one at a time. Yes.
It's in a relationship with the 64 degree angle, not the 154.
Why?
Because 64 is on a parallel line, which is the transversal, and the other one's not parallel. So you would have to use.
Okay, I think Marion wants to have time for rebuttal. Yes?
Why can't it be both? Because it could be supplementary in relation to the 154 degrees, but congruent in relation to the 64 degrees.
All right, well, let's talk about that first. Why can't it be both? Well, if it was congruent, this would be 64, and supplementary would be 26.
Shoot.
It can't be both. Okay? Jake, did you have a thought?
I thought because the transversal is the one going through 54 and 1, and the other two lines are parallel, I think one is 54.
You mean the 154?
Oh, it's 154.
Yeah, I changed that. So you think one is related to the 154? Okay, Jake is correct. We want to not go, and this is where people get confused by this at the very beginning, and then they get it straightened out. We want our transversal to cross two parallel lines, not be one of the parallel lines. So here, we want our transversal. If we're looking at angle 1, the transversal needs to be this line. Okay, then angle 1 and the 154 are supplementary because they're same side interior. So we just do 180 minus 154. We get the measure of angle 1 is 26 degrees. Actually, it looked like you were going to say something there for a second.
So does that mean like you can automatically rule out that that number 26 is not corresponding with 64? And
Well, what do you mean corresponding?
not
You're using corresponding for something that you don't really mean.
alternate
Okay, so
angles?
these are still alternate interior angles.
Yeah.
They just don't have a relationship because the lines that form them are not parallel.
So like, if say you're just doing this on paper and like you do a second, will the parallel lines ever be a transversal?
Yes, if like sometimes you'll have both sets of lines are parallel.
Okay.
If both sets of lines are parallel, then it's actually not a very interesting problem. Because just real quick, since you brought it up,
Everything's the same.
yeah, if you had two sets of lines that you knew were parallel, you don't need to draw this, just watch for a second. So if that's parallel to this is parallel to this, and this angle is, oh, we'll make it super easy on ourselves. Let's make it 100. Then that's 80, that's 100, that's 80, that's 100, that's 80, that's 100, that's 80, that's 100, that's 80. It takes longer to write it than it does to know all these things because we can go either direction. Okay, so that's, like I said, not a super interesting problem. What's more interesting is where you have to decide which line you want to use as the transversal. So like if you're trying to find angle 2 in this picture, is 2 going to be related to the 154 or is 2 going to be related to the 64? 64, because again, we want our transversal to be going across the two parallel lines, so angle 2 is 64 degrees. Now, what about this problem? Is angle 1 related to the 123 or is angle 1 related to the 67?
123.
To the 123. Again, we want our transversal to cross the parallel lines. So we'll just do 180 minus 123. And that's 57 degrees for angle 1. What about angle 2? What angle is it in a relationship with?
67.
The 67. And occasionally I have students who don't like that because they're like, well, those aren't any kind of angles. How can it be in a relationship? That's a good question. It's not a direct relationship. We know that if this angle is 67, its corresponding angle down here should be 67 also.
So it's the
That's a linear pair.
supplement.
Yeah, then these two are going to be supplementary because they're in a linear pair. So it'd be 180 minus 67. It's 113 degrees. So in the end, some people will go, oh, well, if the parallel lines are going up and down, then I need to work side to side. And if the parallel lines are going side to side, then I need to work up and down. I want to be going across the parallel lines.
Couldn't you just flip your page?
Pardon?
Couldn't you just flip your page?
Well, then the numbers would be sideways. So do you like it when the parallel lines are horizontal or when the parallel lines are vertical?
Right.
Interesting. I prefer them when they're horizontal. I don't know why. I just do. It's not a big deal, though. It's not like, it's so much harder when they're the other way. It's like, eh. Okay. Moving along. Let's take a look at this one. Sometimes they won't draw the entire lines. If you want to extend these so that you have lines instead of segments, that's fine. I don't. I think it makes the picture really messy. But on this one, so for angle 1, is angle 1 related to the 128 or to the 123? The 123. And what type of angles are angle 1 and the 123? Okay, supplementary would be how they're related. The type of angles is same side interior. So yeah, it'd be 180 minus 123 is 57. I gotta ask, because you guys are smart people, when you're subtracting this, are you still borrowing?
Yeah. I'm gonna be honest. Yeah.
Okay, so let me just say, one of the things I'd like you to become better at as math students in general is become better at doing mental math. I'm not going to teach you a bazillion tricks. There are a billion tricks for doing different things in your head with math.
On the first day of senior teach, you did like a trick on how to multiply two-digit numbers by a two-digit number, and there was a trick on that.
Yeah, there's all kinds of different ones that you can learn, but let's think about the numbers on this. Okay, if it was 180 minus 120, would that be easy? How much would it be? 60. I'm taking 3 more than that, so it's 57.
So you're doing an easier problem and then adding what you left off in the previous problem.
Correct, yeah. Instead of trying to do it all at once, make it 2 easy problems. Okay, that's just an example, and I'll try and talk about that more because I think all of you need to get some practice in of not having to count on your fingers or borrow and all this other kind of stuff.
We have a subtraction unit then?
No, but we'll be doing subtraction in problems, and I'll point out things where it's like, hey, wouldn't it be easier to do this? I almost never, especially if it's something that ends in 0, I almost never think about borrowing stuff.
Oh yeah, not borrowing, but like something like that.
So anyway, and then for angle 2, what angle is angle 2 related to?
128.
The 128. Again, because we've got our transversal going sideways. So we'll take 180 minus 128. Use that same idea again.
52.
Be 52. Okay? All right. Now, for a new kind of problem that you have never done before, this is an example of something that's called a proof. We'll be doing some proofs in this unit, some in the next unit. The one after that, I don't think we do any, and then the one after that, it's almost all proofs. Okay? So, yeah, I think they're interesting. I don't expect them to be everybody's favorite thing, but here's how they work. In a proof, you'll have a diagram almost always, for this class always, but occasionally for other classes, when you do proofs, you don't have a diagram, and some given information. And from that given information, what you want to do is make a series of conclusions with an explanatory reason. How do I know I can say that? A series of steps until you get to what it is that you're trying to prove.
Will we ever be unable to prove something?
No, I'm mean, but I'm not that mean. Okay? Yeah, I've actually, heard stories. I don't think I ever had a class where they did that, where they said, prove this, and it was unprovable. It wasn't true.
They're always true, we just have to explain why.
Yeah, you can actually prove something is false by assuming that it's true and then working to some sort of a logical conundrum where it's like, well, that means 2 would have to be equal to 3, so this is obviously wrong.
Did you say alogical or illogical?
A logical conundrum. Conundrum? Do you not know that word?
Nope.
A conundrum is where you're caught between 2 things. Frequently, it's like a choice. You have a choice between this, and it's like, I don't know which to choose. Either they're both bad or they're both great. Would you rather die by being set on fire or die by drowning?
Probably drowning, I'm not
I
gonna
don't know. I'm gonna definitely say
Neither sounds particularly appealing, but as a friend of mine says, there's really no easy way to leave the planet.
Or actually, like, dying in your sleep, like, when you're older, it's kind of nice. Like, it's a peaceful way to go.
There's a joke about that.
Why is
So
there a joke about
when I die, I want to go peacefully in my sleep like my grandfather did, not screaming in terror like the passengers on the bus.
Oh my gosh. He's the bus driver.
Oh. Oh my
That was
gosh.
kind of.
Oh. Oh my gosh.
That assumes that he's like maybe the driver on the bus and he fell asleep and yeah. Okay, man. Anytime you have to explain your jokes, it's not going to go well. So for these, one of the most common ways to do a proof is to do what's called a two-column proof. Your first column will be your statements, and your second column will be your reasons. Every reason has to be either the given or a definition, a property, a postulate, a theorem, something you have already showed is true. I usually start with all of the given. Your book has a tendency to break the given into multiple pieces. And you're welcome to do that if you want. This requires slightly less writing, so I'm all about it. And I always will mark the diagram as I go. It's not really a huge deal at this point because these are going to be relatively short proofs. The diagrams aren't terribly complicated. But as we go, the diagrams will become more complicated and the proofs will be longer. By the time we're done with the congruent triangles, you'll be doing 7, 8-step proofs and you'll be like, no big deal. And Mary made a face. All right, so let's start. If R is parallel to S, so this line parallel to this line, what do I know about any of these angles if R is parallel to S? Do I know what? No, what do I know about any pair of angles on here? They're all congruent because R is parallel to S.
Complementary and supplementary based off their relationship. Well,
I'm talking about the numbered angles there are 3 numbered angles, 1, 2, and 3. If R and S are parallel, there's a relationship between 2 of those. What 2 is that?
2 is congruent to 3
Yeah, angle 2 is congruent to 3. How come?
because they are corresponding angles.
Exactly, and they're corresponding angles and the lines are parallel. So angle 2 is congruent to angle 3 is going to be my statement. I have to justify that statement with a reason. Well, that's the corresponding angles postulate. Remember, that's the only one that's a postulate in this unit. So I know angle 2 is congruent to angle 3, and I'll mark that on the diagram also.
Are there, you know how for theorem it's just, we can write it THM with a line under there?
Yeah. If you want to abbreviate postulate POST, that's fine.
Okay.
Okay, now we're not quite where we want to go, right? We don't want angle 2's congruent to 3, we want angle 1's congruent to angle 3. So we need something that's true about angle 1. Well, if A and B are parallel, then what other conclusion can we make? Yes.
1 and 2 are congruent
Because?
of the alternate interior angle theorem.
Exactly right. We know this is true because of the alternate interior angles theorem. Okay, now, if angle 1 is congruent to angle 2, and angle 2 in turn is congruent to angle 3, then what?
3 and 1 are congruent.
Yeah, then 1 would have to be congruent to 3, but we need a reason for that. And 1 and 3 aren't any kind of angles, so we can't appeal to that. So we're going to have to use a property. You guys haven't learned these yet, but we're about to learn our first one. This is called the transitive property. And notice what I had up here. I had 1 was congruent to 2, and 2 was congruent to 3. Do you see how that kind of follows this trail of things? Starts at 1, goes to 2, then 2 goes to 3. Anytime you have a chain of things like that, that is the transitive property. Basically, the transitive property says something like this. You don't need to write this down. But if A was equal to B and B is equal to C, then A is equal to C. Anytime I have that pattern, and you can use it, I let people use it for congruence. Your book says the transitive property of congruence. And I'm like, whatever. It's the transitive property. And how do we know we're finished? When we get to a statement that matches my proof and have given a reason for it. Okay, let's do some more of these. I left you tons of room. All right, so in this diagram, we've got that J is parallel to K, and we want to prove that angle 1 and angle 3 are supplementary. So that's going to be a little different than the last one. We'll do a 2-column proof on this one, and then on our next example, I'll show you a different format. Yes, Marianne?
I have 2 questions. If we were ever doing more advanced proof, you just mentioned a different format, but would there ever be like 3-column, like?
No.
It's always just 2?
Yeah, it's always just 2 columns.
And also, can I go to the restroom, please?
Run like the wind.
Thanks. I'm running.
It's the slowest wind ever.
It's a breeze.
All right. So we're only given here that J is parallel to K and the diagram to help us out. So if J and K are parallel, is there a conclusion that we can make about a pair of the angles here? Yes, ma'am.
1 and 2 are corresponding.
So that's true. And because that's true, what conclusion can we make?
That 1 and 2 are congruent.
They're congruent. Yeah. The statements are always going to be about relationships. Okay? So we can start by saying that angle 1 is congruent to angle 2.
Do we have to write like corresponding angles postulate every time?
Yep. So that's what this is going to be. This is the corresponding angles postulate. The problem is if you just write corresponding angles, I'm like, well, what about them? The postulate tells you if the lines are parallel, corresponding angles are congruent. And once upon a time, almost everybody made students write out the entire postulate or theorem. So instead of writing just corresponding angles postulate, you had to write, if 2 parallel lines are crossed by a transversal, then any pair of corresponding angles are congruent. There's a lot of writing. Okay? Now, for this one, you might get stuck at this point. You're like, there's nothing else true because of the parallel lines. But, yes.
2 and 3 are supplementary because they are already in there.
Exactly. Very good. Angle 2 and angle 3 are supplementary. And from our reason here, we'll say because the angles in a linear pair are supplementary. That's a short enough one to where I don't ever use the title. Now, if angle 2 and 3 are supplementary, and angle 1 and 2 are congruent to each other, yeah, 1 and 3 are supplementary. Now, this is just one where I kind of play a little fast and loose with the strict definitions of things. I'll go ahead and say angle 1 and angle 3 are supplementary. I'm sure I have some colleagues that are my age or older who would, be spinning in their grave if I told them about this, because they'd be unhappy about it for the next 30 or 40 years. Okay? Because I let students do this by something where I'm like, well, what have I done to this statement? Angle 2 and angle 3 are supplementary. To get this statement, angle 1 and angle 3 are supplementary.
You said that 1 and 2 are, what do you call it, congruent?
So my question is, you haven't answered my question at all. I said, what have I done to this statement to get this statement? Pardon? This statement looks exactly like this statement? Yeah, I've replaced angle 2 with angle 1. And the reason I can do it is because they're congruent to each other. Now, I call that, and I let students use this, substitution. Many textbooks will say you can't substitute into a sentence. Strictly speaking, substitution is a property of equality, so you can only do it in equations. I take a broader view of it, and it's like, it's the same size, I can replace it. The logic's the same. It's just extra steps. Okay? All right. So substitution in the transitive property. When you have a chain of things, that's the transitive property. When you take something out and replace something that's the same size in a sentence or an equation, that's substitution. Moving on. Let's do this, and we're going to do this one in a different format. Okay? You're not going to be required to use a particular format on your quizzes and tests. I leave that entirely up to you. But some people like these. So, for this one, I'm going to do what's called a flowchart proof. Let's say M is parallel to N. I'm going to put a little box around it. Every statement is going to have a rectangle drawn around it. And underneath each statement is going to be the reason I know that that statement is true. This is true because it's given. I know that M is parallel to N. And anything that is true because of that, I'll draw an arrow to the next statement. So if M and N are parallel, what conclusion can I make based on that? Yeah, angle 2 is congruent to angle 3. I got to be able to give a reason for that. Yeah, the corresponding angles postulate. And that's pretty much as far as I can go with that particular thought. Well, I have another part to the given. I know that J is parallel to K.
Since it starts off with a different thing, would we just start like another row?
Yeah, usually that's what you do. You start another row. So once you kind of get finished and it kind of peters out, you go to another row and start a new one. And what you're hoping is that they're all going to converge on one thought.
So you'll end with pretty much them all saying the same thing, so you can prove it?
You'll end with all of them will come together to give you your final conclusion.
So like they're all going to come together over here?
Yeah.
Oh, okay.
Yeah. So this is given. What conclusion can I make based on that?
That 1 and 2 or something.
Yeah, 1 and 2 are supplementary because they're same side interior angles. So angle 1 and angle 2 are supplementary.
Is that the interior? No.
What kind of angles are 1 and 2?
Same side interior.
Right.
Sorry, I totally forgot that.
So it's the same side interior angles theorem. Okay. Well, now, if I know angle 1 and 2 are supplementary, and angle 2 is congruent to angle 3, what new conclusion can I make based on those two things together?
Angle 1 and 3 supplementary.
Exactly. So this and this combined let me know that angle 1 and angle 3 are supplementary. And what reason could I give for that?
Substitution?
Yeah, that's substitution.
Yeah, that's the best.
You may. So some people like flowchart proofs better than two-column proofs. I like them for short proofs. When we get to longer proofs, they start to get a little bit messy. The reason I like them is because it kind of shows you the logic. It shows, well, for this step, I'm using these two steps together. Okay? This is coming from what I know about this. It shows more about what you know. And for the proofs that we're doing on these, none of these are going to be more than 4 or 5 steps long at this point. So flowchart proofs work really well. All right, I think we've got one more. That's a scary looking diagram, isn't it? Let's see what we can do with it. Let's do a flowchart proof again.
Would you still consider this a small proof?
It's not going to be terribly long. So I know that J is parallel to K, because that's given. And one of the things you want to do in any proof is you would like to say things, you want to keep your eye on the prize. Meaning, what is it that we're eventually trying to prove? We want to eventually prove that angle 3 is congruent to angle 4. So whenever possible, we'd like to say something about one of those two angles. It won't always be possible immediately, but we'd like to say something about one of those, or maybe even both of them. Yes?
Never mind. Never mind.
Okay.
Sorry.
Do you see any, if these two lines are parallel, do you see any angles that either 3 or 4 would be in a relationship with?
3 and 1.
3 and 1? Yep. What kind of angles are those?
Alternate interior.
Yeah. Angle 3 is congruent to angle 1. That's the alternate interior angles theorem. Is there anything we could say about angle 4 at this point?
It's corresponding with angle 2.
Yeah. Okay. So because it's a corresponding angle with angle 2, we could also say, for this same reason, or from the same given, that angle 4 is congruent to angle 2. And that's the corresponding angles postulate. Now at this point, does it make sense logically to just put these two in a bag and shake real hard and say that angle 3 and angle 4 are congruent? They're not related to the same things, right? 3 is related to 1, 4 is related to 2. I haven't gotten there yet, but notice there's another part to the given. Let's use that. So since this is a new one, like you were talking about earlier, Marion, since I've kind of run out of things to do with this, I'll come down and do another row. BA bisects angle CBD. That's given. What is a bisector? Now you have to dig deep. What does a bisector do to an angle? Yeah, that's not what the definition says, though. What does the definition say?
Oh, it cuts them into equal parts.
Closer.
Divides an angle equally into 2 parts.
Divides is good. Equally, not so much. Pardon?
Congruent.
What about congruent?
The two angles that it bisects are congruent.
Well, it only bisects one angle.
The 2 angles it creates by the bisection are
It bisects an angle. Wait, it bisects an angle and makes 2 congruent angles.
Okay, that's really close. A bisector divides one angle into 2 congruent angles. Well, you have to know what it says because otherwise you won't be able to make the right conclusion.
We know like the exact definition.
You're not going to have to be able to state it word for word, but if you don't know it, then you're going to have trouble making the right conclusion. So if BA bisects CBD, what conclusion can we make based on that? Here's angle CBD. I'm sorry?
Angle 1 is congruent to angle 2.
Yeah, angle 1's congruent to angle 2.
And then we can go and we can swap them.
So this is because of the definition of angle bisector. The definition of an angle bisector says if you have an angle bisector, it divides that one angle into 2 congruent angles. Well, oh, hey, look. 3 is congruent to 1. What's 1 congruent to?
2.
2. What's 2 congruent to?
4.
4. Oh, look, we've made this long chain of things.
You have to write out a chain like you did before.
I was just showing you that.
Okay.
So combining all 3 of these things, we can say now that angle 3 is congruent to angle 4. And that's using the transitive property. And I do make you on this one do one other thing, is we really have used 2 different parts of it. We used the transitive property and then we used the transitive property again, right? We went from 1 to 2, from 3 to 1 and 1 to 2, so 3 and 2 are congruent. And then once we have that, we said 2 is congruent to 4, so 3 and 4 are congruent. I just make you say, I used it twice. It's kind of obvious in a flow proof, in a flowchart proof, because you're bringing all those things together with the arrows. In a 2-column proof, it's not nearly as clear. So it's required that you tell me I've used it twice.
Is that why you told us to do a flowchart proof in this preview?
No, not necessarily. Although I do like how all those arrows show you, yeah, I'm using all 3 of these things at once. Okay? All right, any other questions? Okay. What is your assignment today? It's a worksheet. Woohoo!
Wait, we have homework.
Yes.